Hello students! Today we're going to learn about Unit 5, Lesson 5.5, Magnets. On your student book, it is on page number 80 to 81. The learning objectives of this lesson: first, to identify the different types of magnets. Second, to explain the forces between magnets. So at the end of this lesson, you will be able to identify the different types of magnet and to explain the forces between magnets. To begin with, let's do pre-assessment. For your pre-assessment, you will have an online game. This is the link on how to join the online game. The game code will be provided during the class. And the time allotted for this pre-assessment activity is only 3 minutes. Now, for your workbook activity, on the right side of your notebook, write the meaning of the keywords that you can see from the glossary of your book. The keywords are magnet, pole, and force. So you're going to look the meaning of the following keywords from the glossary of your book. Now, it's time for discussion. You have probably seen and used magnets before. The photographs show some of the magnets that you may have seen around you. Which of these magnets have you seen? Where else have you seen magnets? What were they doing? There are also powerful magnets inside speakers and computers' hard drives. What is magnet? When we say magnet is an object that attracts iron and a few other metals. Magnets are rocks or metals that create an invisible field around themselves. These fields attract other magnets and certain metals. Magnets attract steel because it contains iron. There are different shapes of magnets. Some are like bars, some are U-shaped, some are thin and flat. Now, let us see the different types of magnets. Magnets comes in different shapes. The most common shapes used in school are bar magnets and U-shaped magnets, but you also get circular magnets, ring-shaped magnets, and round magnets. The flat-shaped like fridge magnets are made from fine magnetic powder mixed with plastic. These are the different types of magnets. It comes in different shapes, just like bar shape, ring shape. It comes also into this shape and another one, which is the magnetic needle and a horseshoe shape. Now, look at this bar magnet. The two halves are painted different colors and labeled as N and S. This is because magnets have two poles, the north and the south pole. The magnetic force exerted by magnet is the strongest at its poles. Now, let us see how magnets work. You know already what is magnet. Magnets attract magnetic objects and it comes in different shapes. Magnets have two poles termed north or north-seeking and south or south-seeking. Some magnets are stronger than others, but the strongest parts of any magnets are the ends, where the force field is concentrated. Only magnetic materials are affected by magnetism. The only common magnetic materials are iron and steel. The correct term for the magnetic effect is a field. The field acts upon the magnetic material to create a force. Magnetic field is the space around a magnet over which a magnetic force exists. Let us learn how the magnet works. For a bar magnet, the field is most concentrated at the ends. And for the horseshoe, a horseshoe magnet is effectively a bar magnet that has been bent into a curve that brings the poles together and produces a strong magnetic field. So remember, a magnetic field is the space around a magnet over which a magnetic force exists. To understand more about magnetism and how the force exerted by a magnet, watch the video carefully.
You must have seen a magnet with this shape before. It's called a bar magnet. It looks like a chocolate bar. What happens if we bring it near an iron nail? We know that as we bring it closer to the nail, at some point the nail moves towards the magnet and sticks to it. Moreover, it remains there until we manually separate it from the magnet. So why does an iron nail stick to the magnet? This is because of the force of attraction that binds the magnet and the nail together. This force is applied by the magnet on the nail and hence it's called a magnetic force. Here is one interesting question that I want you to answer. Is magnetic force a contact force? In other words, is the contact between a magnet and the nail necessary for the magnet to attract the nail? Let's look at the animation in slow motion. We are moving the magnet towards the nail. And at this point, the nail also begins to move towards the magnet. It means the force came into action even when there was no contact between the magnet and the nail. Hence, we can say that a magnetic force is not a contact force. Contact is not necessary for the magnetic force to work on the nail. To understand this better, we bring this magnet close to the nail and move it slightly up in the air. You will find a slight movement in the iron nail as well. This means that the iron nail is under the influence of a magnetic force even though it's not in contact with the magnet. It again proves that a magnetic force is not a contact force. So we can say that it's a non-contact force. The force exists even though the magnet is not in contact with the iron. But what does this non-contact nature of the magnetic force tell us? It tells us that there is an invisible field produced by the magnet in the space around it. And if you bring any ferromagnetic material in this field, then it experiences that force of attraction. We cannot see this field, but it exists. This field is produced by a magnet and hence it's called a magnetic field. Now I'll ask you an interesting question. Do you think the strength of this field is even throughout the area around the magnet? Let me explain this to you with a relatable example. Assume that there is a working Wi-Fi router present at some location. It gives off signals in all the directions in some range. Now, in order to connect a mobile phone to the internet, we need to bring it in this range only. This signal will be stronger nearer the router. The closer you bring your cell phone to the router, the stronger the signal will be. One can think of magnets in the same way. A magnet has a magnetic field around it. The strength of this field is greater closer to the magnet and decreases as we go further away from it. As you bring any ferromagnetic object in this field, it experiences a magnetic force. The closer we bring that object to the magnet, the greater the force it will experience until at some point where the force will be large enough to make the object leap towards the magnet.
You have learned already what is all about magnets. What are the different types of magnets and how the magnets work. To check your understanding if you really understood the lesson, let's do the online game. This is the link on how to join the online game. For additional activities to this lesson, see the homework task PDF uploaded in the school portal. Follow the instructions and do each task. That's all for today. Thank you and have a good day.